हेलो फ्रेंड्स, नमस्कार। क्लास 11 चैप्टर 6 वर्क एनर्जी एंड पावर के एक और सेशन में आप सबका स्वागत है। पिछले सेशन में हमने डिस्कस किया था वर्क। क्या डिस्कस किया था बच्चों? वर्क। मैं उसका फॉर्मूला लिख देता हूँ। वर्क डन बाय फोर्स, वर्क डन बाय फोर्स इज इक्वल्स टू फोर्स मल्टीप्लाई बाय डिस्प्लेसमेंट इन डायरेक्शन ऑफ फोर्स। ठीक है, यह फॉर्मूला आप अच्छी तरीके से याद कर लीजिए। अभी तो 11th चल रहा है, लेकिन 11th 12th और आगे बहुत सारी जगह पर यह फॉर्मूला आपको काम आने वाला है। वर्क का सिंबल है W। अगर सिंबॉलिकली में लिखना चाहूँ तो W इज इक्वल्स टू एफ आर कॉस थीटा। आप एफ डी कोस थीटा, एफ एस कोस थीटा सब कुछ लिख सकते हो। Where F is the applied force, R is the displacement of the object on which the force is applied, and theta is the angle between force and displacement, applied force and the displacement. That what we have discussed in the previous lecture. Okay, today we are going to discuss two important forces. One is the conservative force and another is the non-conservative force. Okay, it is very important to discuss these two forces. One is the conservative force and second one is the non-conservative force. We will start our discussion with the conservative force. So give heading conservative force. Conservative force. Okay, this is completely new for you. What is conservative force? Conservative force means what? Force for which work done does not depend on path. Okay, simple, very simple. Okay, force for which work done does not depend on path. Okay, suppose you are moving any object, okay, from A to point B. Okay, suppose distance between them is the D. Okay, and suppose one block is there. Okay, block is having mass M, and you are applying force like this. The force applied is the F, and suppose that mass has moved from A to B. Okay, the mass has moved from A to B. So now if it is asked what is the work done, then what will be your answer? It's very simple. F into D. Yes or no? FD cos 0. FD cos 0 degree. So what is the answer? It is the FD. Clear? Now suppose that we choose some different path. Okay, which path I am choosing? See carefully. A to this to this, and this to this. Okay, means A to C, C to suppose E, A to C, C to E, and E to B, and this is nothing but D. Okay, C is equals to D. So suppose the object is moved from the path A to C. First of all from A to C, then C to E, then E to B. Okay. So what happens actually? See here. Total work done, W total. Total work done is equals to work from A to C plus work from C to E plus work from E to B. Clear? Okay. Now see carefully here. Work done from A to C. It is equals to force applied. Okay, the force applied is this much, F. Okay, and multiply by AC. Okay, so see here in the path AC that you are moving downward. Okay, downward or in this way as the given, and force applied is like this. So what is the angle between them? 90. So here I have to write cos 90 plus F. Okay, and C. Okay, and here also force applied is in the same direction F. Okay, so here cos 0 degree plus EB, F into EB into cos 90. Okay, why? Because force applied is in this direction and displacement is in this direction. So what is the angle between them? 90 degree. So what will be the answer? Answer will be is equals to cos 90 is equals to 0. I think you know. So this work done will be 0. Now C nothing but equal to D. So this work done will be equal to FD plus 0. So what is the answer? Answer is the FD. Clear to you? Okay. Any path you choose, whatever path, suppose this path you choose, okay, in which your initial position is the A and final position is the B, then what will be your work? So if somebody asks what will be your work and applied force is the F as it is given, then your answer will be W is equals to FD. What will be the work? W is equals to FD. Means what? For different paths. See, here we have selected three paths. One is a straight directly from A to B, one is from A to C and C to B, and another one is this random, as you can see. Okay, in all these three paths, what we see is that work done is the same. Work done is the same means what? That work work done does not depend on path. Work done does not depend on path. Or what you can say, it depends on work done depends on initial and final position. Can you say like this? Initial and final position. Suppose let me explain you again this, that suppose this is a and this is a B, and suppose distance between them is a D. Okay, and you are moving some particle from A to B by this random path, and if someone asks you what is WAB, your answer, suppose the force is like this. Okay, so it will be the FD. Clear to you? It's very simple, right? Now, suppose point is not B, but point is the C, where distance between A and C is suppose D1. And now suppose someone asks you that what is work done from A to C, then your answer will not be FD. Your answer will be F into D1. Why? Because see, initial and final position. Initial position remain as it is, but final position got changed. So what? See, suppose I move this particle from A to C in a this way. Okay, so work done will also get changed. So what you can say, it depends on the initial and final position. That you can say it is a point function. Point function. Okay, and suppose I am selecting one point E. So how much is the work done? This much is the distance. Suppose this distance is the D2. So if someone asks you that what is the work done from A to E, your answer will be F into D, suppose this is D2, so FD2. Okay, means as I bring the point, final point nearer to the initial point, work done decreases, yes or no? And what if I do like this? See, I am drawing some path. I am drawing that you are moving any object from A, okay, and via some path, and then after, okay, again to A. Again to A. So what you can say here, this is a closed path. What you can say, this is a closed path. Okay, closed path means what? Same initial and final position. Same. Initial and final position. And what will be the work done? W closed path is equals to closed path is equals to force into. Now initial and final position are same. That's why displacement is the 0. So what will be your answer? 0 joule. Okay, clear or not? Here, so what we get is the work done, work done in closed path. Work done in closed path is 0. Please note it very carefully. Okay. Such force are known as such forces are known as such forces are known as conservative force. What we will say them as a conservative force. Okay. So what you got today? And what is conservative force? The force for which work done in closed path is of 0. Mathematically, if I write mathematically, then closed path. This is the symbol of a closed path. F bar dot dr bar is equals to 0. Okay, such force is known as the conservative force. Okay, because initial and final position are same. See, we have discussed the conservative force, in which we have discussed two important points regarding a conservative force. One is the point function. What we have discussed, point function means what? It depends on initial and final point only. And second one is that work done equals to 0 for closed path. Which type of path? Closed path. Okay, such force are known as the conservative force. Okay, remember very carefully. Okay, it is much useful. Work done in closed path is a 0, and that force is known as the conservative force. You will say, sir, for any type of the force, work done in the closed path will be 0. No, it's not like that. We are going to discuss that forces in which work done in closed path is not 0. But first of all, let me give you some examples. Examples of conservative force. Examples of conservative force. First and very impressive, important, interesting. Okay, the example of the conservative force, that what you are waiting for is the gravitational force. Okay, gravitational force. Okay, gravitational force is which type of force? Conservative force. One more force is the spring force. Spring force is also which type of force? Conservative force. Okay, one more force I remember. Electrical force. Electrical force. This electrical force is also a conservative force. One more force I remember. Magnetic force. Magnetic force. This force is also conservative force. Okay. In 11th, we are going to discuss these two forces mainly, gravitational force and spring force. While in 12th, we will discuss detail about this electrical force and magnetic force, electrodynamics, generator, motor, blah blah blah, much things. Okay, light and all that. So that we are going to discuss in the 12th regarding this electrical force and the magnetic force. You can say that the electromagnetic force like that. Okay, gravitational force. See, we have one chapter special gravitation. Okay, in the 11th standard, and we are going to discuss much these two forces. One is the gravitational force and one is the spring force. See, let me give some introductory data. Suppose this is the object number 1 having mass m1. This is object number 2 having mass m2. And suppose distance between them is the r. Then what is the gravitational force? Gravitational force is g m1 m2 upon r square. Guys, let me tell you that this is our earth. Okay, and this is the radius of the earth. You know what is the radius of the earth? It is nearly 6400 kilometer. Whoa, It is much larger than our height. Oh, not our height. Burj Khalifa also is much shorter than this. Okay, no problem. But suppose like that Earth as a one object is having mass m, and we are somewhere here. And what is our mass m? Okay, so what is the gravitational force between ourselves and the Earth? The gravitational force is nothing but G, Earth mass, our mass, divided by distance between our center and the Earth center, which is, and we are neglecting this much height. Okay, so which is nearly equal to radius of the Earth, Gm upon R square. So see, this force for any object, this G, capital G, this is universal gravitational constant, capital M, mass of the Earth and radius of the Earth. They are constant nearly, okay, on the surface of the Earth. So what we consider them as a G. Remember G, free falling body, M. Okay, good morning, not good morning. It is a mg. It's a weight. Okay, what is this? Weight. That is the gravitational force. Okay, let me give you one example. Suppose, see, it is very simple to understand that gravitational force is which type of force? Conservative force. Much easy to understand. See, very simple. Suppose this distance is, this is a theta. Okay, this height is a h. Okay, this is a, this is a b, this is a c. Okay, this height is a h. Let me tell you like this. Okay, and suppose there is a block, one block is having mass m. Okay, is moved from a to c. This is path number 1, and let me give you another path like this. This is path 2. Clear? Okay. So work done in path AC. What is the gravitational force? Gravitational force here. It is like this. Okay. And this is a displacement. Okay. So work done is equals to mg. Okay. And what is the displacement? Displacement is the SC. And see, what is the angle? This is a mg. Okay. This much is the 90, and this is a theta. So this is what? Cos 90 plus theta. Now what is cos 90 plus theta? Mg into Sc sin theta? No, minus sin theta. Okay, so what is the answer? Minus Mg into Sc sin theta. Okay, now see from this diagram. Okay, I will draw a diagram again. This is a, this is a B, this is a C, and this is a theta, right? Okay, so now suppose you take sine theta. Sine theta will be equals to what? It will be opposite upon hypotenuse, so it will be CB upon AC. Clear? CB is what? H upon AC. Implies H is equals to what? AC sine theta. You can say like this. AC sine theta. So AC sine theta is nothing but H. So what will be the answer? Answer is a minus mgh. Okay. Now again, let's calculate work from A to B plus work from B to C. Okay. You can say that from when you are going from A to B, at that time you are moving horizontally. Where you are moving horizontally, and gravitational force is acting in the downward direction. So what is the angle? 90 degree. So that work done will be 0. And then after, when you are going from B to C, see, when you are going from B to C, at that time how much force is acting? Mg. Okay, it does not change. So force is the mg, and then after how much is the displacement? Displacement is equals to h. And see, displacement is in this direction. So what is the angle between them? 180. So cos 180. Cos 180 is how much? Cos 180 is minus 1. So what is the answer? Minus mgh. So see, you can see that work done from first AC and work done from this AB plus BC. Both are same. Means it does not depend on the path. Clear or not? So here we have proved that this gravitational force is the conservative force. Let me give you one more example. See, I think now you have understood somewhat the conservative force. What is conservative force? Conservative force for which work done does not depend on the path. Okay, no problem. So this is the M and this is the M. Okay, actually what I have done, I have moved the object. Okay, suppose this is the ground level. Okay, and work done in up motion. Work done in up motion means from bottom to top. Okay, so suppose we have moved distance h. Okay, so what is the force? Mg. How much is the displacement? H. And see, mg is acting always in the downward direction. Okay, and displacement is in the upward direction. So here it will be cos 180. Right or not? It will be cos 180. So what will be the answer? Minus mgh. Is that clear to you? Okay, now again let us think that this block come down. So, work done in downward motion will be is equals to force into displacement into cos 0 degree. See, why 0 degree? Because displacement is in the downward direction as well as mg is also in the downward direction. So, what is the answer? mgh. Now, w up plus w down. W up plus W down. See very carefully. W up plus W down. Closed path. So what is the answer? Minus mgh plus mgh. And what is the answer? 0 joule. So here that also we have proved that work done in closed path by gravitational force is a 0. So now whenever it is given that this mass is moved from this any random path like this or whatever. Okay, whenever it is asked to calculate work done, directly see the distance, means displacement between them, and you will get the answer. Okay. Please don't get confused that every time work done in closed path will be 0. Okay, we are going to discuss it. Be patient. Okay, here I want to discuss one more force, spring force. Okay, spring force. What is the spring force? Let me explain. Okay, it is very important force, so please listen very carefully. Suppose this is a spring and we have a block attached with it. Block is having mass m. Okay, is that clear to you? Okay, fine. Suppose, okay, before that, suppose this is a x equal to 0 and we have moved block here. So as we move block here, what happens? This spring, okay, certainly get stretches. And how much stretch generated? This much stretch get generated x. Okay, and because this much stretch get generated, one force get produced in the spring. One force get produced in the spring. In which direction? In this direction. Okay, that force is proportional to displacement. Whatever you stretch, the more the force will get generated. Okay, and if you want to remove this proportionality sign, then you have to put one constant k. It is called spring constant. Okay, and it depends on the type of material of the spring. Okay, I am not writing, but if you want to write, you can write. I will write F is equals to here minus k. So why minus k? Because see, here we have made displacement in this direction, in positive direction, and the force is acting in the opposite direction. That's why I am putting here a minus sign. Is it clear to you? Okay, this force is called as the spring force. Okay, and spring force, what am I saying? That spring force is best example. Spring force is best example of variable force. Which type of force? Variable force. See, we have discussed gravitational force. Okay, that object is moved from B to top, bottom to top, and top to bottom. In which this gravitational force is not changing. That was constant. Yes or no? But here, what we are discussing is the spring force. Yes, spring force is not constant. Okay, as I have said, the spring force depends on the stretch. Okay, means as the stretch increases, the spring force will going to be increased definitely, yes or no. And one more option that we have, let me discuss that also with you, that it is not only spring force generation when we are stretching the spring. I think you have experienced that also, that if you compress the spring, if you compress the spring, then also uh, restoring force get generated. Okay, and we have made displacement this much. On which side we have made displacement? On this side. It's negative displacement, yes or no? So what you can say, that spring force will also get generated, and in which direction spring force will get generated? In this direction. Okay, F is equals to minus kx. From this definition only, means F is equals to minus kx only, you can say that whenever x is a positive, force will be negative, and if force x is a negative, force will be positive. That's why it is also known as the restoring force. Okay, and it is also an example of what you can say as the conservative force. Let me explain that how. Suppose F is equals to minus kx. Okay, means what we will consider that only already spring is somewhat stretched. Okay, now on stretching spring by displacement dx. Okay, how much work done? Minus kx into dx. Clear to you? This much work done will be there, and total work done will be equals to integration dw. Okay, and which is given as minus kx dx. Okay, so if you make integration, what you will get? Minus k outside, and x dx. What is integration of that? It is x square by 2. Okay, and let me put some limit also, that suppose this is the original position, x equals to 0. You have stretched it from x equals to x1, okay, to x equals to x2. Yes or no? Because we want to prove that it is a what you can say, conservative force. That's why let me put the limit x1 to x2. Initial is the x1, final is the x2. I'm putting here x1 and x2. So what you will get, see here, minus k by 2, x2 square minus x1 square. Clear? See how to replace the limit. First of all, put x equal to x2, means upper limit. x2 is the upper limit and x1 is the lower limit. So what you can say, minus k by, okay, not minus, I will write directly half k x1 square minus half k x2 square. Okay, this is the work done from 1 to 2. So clearly, if I ask you what is work done from 2 to 1, work done from 2 to 1 is nothing but half k x2 square minus half k x1 square. 2 to 1 means what? Simply you have to replace the limit x2 by x1 and x1 by x2, like that. Okay, and you will get the answer. So now if you add them, w1 to plus W21, what will be your answer? 0. Check it. Okay, it is very important force. Okay, here I am giving somewhat introduction, but in future we are going to discuss this force in detail. Okay, in the simple harmonic motion session. Okay, but note it very carefully. We are going to discuss potential energy in future, in which we are going to discuss elastic potential energy. So there also I will derive this equation. Okay, so if you have learned here, then you can get a revision at that position. Okay, is it clear to know? So what you can say, that spring force is also a restoring force is there, but it is also a conservative force. Now let us discuss non-conservative force. Okay, its discussion is very small. Non-conservative force. Okay. So if someone asks you what is a non-conservative force, then what is non-conservative force? That work done is not equals to 0 joule in closed path. In closed path. And second, and work done depends on path. Work done depends on path. Okay. Example of this is frictional force. Best example. Frictional force. Frictional force is which type of force? Non-conservative force. See carefully here. I think you know somewhat about frictional force. Object is moving here. Okay. From suppose A to B. Okay, object is moving like this. So where the frictional force will act? Frictional force will act in the opposite direction. Okay, and suppose the displacement is the D. So what will be the answer? Work done from A to B. Work done from A to B will be is equals to frictional force into D. See, we are calculating work done by frictional force. So I am replacing here force as a frictional force. If it is asked work done by some applied force, then we have to replace that applied force. Clear? Whatever work you have to calculate, you have to replace that force. Okay, and what is the angle between F and D? It is 180. See, frictional force is always opposite to the displacement. Okay, here it is opposite. So cos 180 minus 1. So what is the answer? Minus FD. Now, suppose you are moving block from B to A. In that, frictional force will act in the opposite direction. Guys, you know very well. Okay. So what is the answer? Frictional into displacement into again cos 180. Why cos 180? Because friction is acting in the opposite direction. So what will be the answer? It will be again minus FD. So if you say WAB plus WBA, then what will be your answer? It is equals to minus 2FD. You can see that. Okay, it is not equal to 0 joule, and that's why this it is which type of a force? Non-conservative force. Okay. In general, opposing forces, all opposing forces are nothing but non-conservative force. Okay, it depends on the path. It depends on path. If you select some other path, then friction will act in that path, and you have to calculate that distance. Okay, is that clear to you? Let me tell you that suppose uh, I'm just giving only example that if it is asked here one ball, okay, is moving down here, okay, and suppose radius is the r. So what is work done by friction? Work done by friction will be is equals to friction into this much length, means work done by friction from A to B, okay, will be equals to this much length, and this much length means how much length? See, this is the r, so I think this is a pi r length, okay, into cos 180, because at each and every point you will notice that friction is in the opposite direction. Guys, it is in the opposite direction. Okay, if ball is moving from B to A, then also it is in the opposite direction. That's why, okay, it will depends on this path. Okay, otherwise some other force is there, conservative force, then what will be the work done by this force? Then it will be is equals to simply displacement. Work done into is equal to force into AB into cos theta, like that. Is it clear to you? Okay, so guys, today what we have discussed? Today we have discussed conservative force and non-conservative force. Let me revise you in 1 minute. Conservative force means what? The force it depends on initial and final position and do not depend on the path. Okay, and work done in the closed path is a 0. And what is non-conservative force? Non-conservative force means what? Work done in closed path is a not zero, and it depends on path. Okay. Frictional force is a non-conservative force, while gravitational force, spring force, electrical, magnetic, etc. That forces are a conservative force. Okay. So yeah, today we have to discuss only this much, and in the next session we are going to do the next topic. Okay. Thank you and namaskar.